Okay, guys, today I want to talk about, I just want to explain the scale model assignment here. So I'll just begin by reading this and you guys can just follow along here. Cells come in many different shapes and sizes. Most are so small, they are measured in micrometers or microns. That's that little symbol here with the weird U. This is a micrometer, okay? I'm on eraser. That's a micrometer. A micrometer is one millionth of a meter. So if you took a meter stick and you broke it into a million pieces, that's how small a micrometer would be. And that would be too small for us to even see with our eye. So anyway, the smallest objects that the unaided human eye can see are about zero point 0.1 millimeters long or 100 micrometers long. That means under the right conditions, you might be able to see an amoeba, a human egg, and a paramecium without using magnification. Magnifying glass can help you to see them more clearly, but they will still look tiny. You will be creating a scale drawing that is much larger than the average cell. The scale of our model is 1 micrometer for every zero point 0.5 centimeters. Okay, so the point of a scale model is to draw it bigger than it actually is, but to keep the proportions correct. A lot of the drawings that we see of cells in books and just wherever are not actually the correct size. So we are going to draw a scale model that is the correct size. You can probably think of other applications for scale models, maybe architecture, for example, where that is drawing something smaller than it normally is. We're drawing something bigger than it actually is. So here's what the scale means right here. For every 1 micrometer, that's how big the cell is, we're going to draw zero point 0.5 centimeters. So, for example, average plant cell. Now, remember, a plant cell is going to be kind of blocky shaped. So, for this like 40 by 40 means 40 over there, right? But we have to change it into centimeters. Okay, so it means here we have 40 micrometers. So for every one of those micrometers, you're going to draw half a centimeter. So essentially, what that is going to, the math of this is just going to be you take the number here, the 40, you times it by zero point 0.5, which is the same as dividing by 2, and you get 20. Okay, so this becomes 20 by 20 centimeters. Okay, and then that is how big you will draw your cell, like the outside of your cell. You're going to need either a blank piece of paper or you can use a lined paper too, but you're going to need a ruler, okay? A metric ruler, one with centimeters, okay? All right, let's do the next one. So again, we're basically just going to take this. Actually, let me show you the math. So 14 micrometers. That's like saying anything is 14 over 1 is itself. So we're going to multiply that by 0 0.5 centimeters per micrometer. And so these things cross out. We're left with centimeters, and 14 times 0.5 is 7, right? So this 14 becomes 7 centimeters, and the 20 becomes, the 20 becomes 10 centimeters. So 14, 7 by 10 centimeters. Okay, so you're going to draw this thing, the central vacuole, that size, right? Now, how do you know what it looks like? Well, I also um, put a picture there. So this is a pretty good drawing of a cell, but not everything is to scale the way that I want you to have it. So you're going to get these measurements, right? So let's say that it was central vacuole, and it was 7 centimeters by 10 centimeters. So let's say we have the big old cell right here. I don't just want you to draw so here's, let's say that's 7, and then this is 10. I don't want you to just draw a perfect rectangle, okay? This is not what the cell actually looks like. So I want you to draw kind of some of these shapes in here that are already labeled for you. So I want you to draw them what they actually look like, and you're going to make it roughly this size. So please don't draw just like a bunch of perfect circles and perfect rectangles or squares in your cell. I want you to draw it what it actually looks like. Okay, you can look up other pictures online too if you want other pictures. So for this, for that central vacuole, I might draw it, it's a kind of a big blob, but maybe this was my 7. It was about 7 this way, and it was about 10 this way. Okay, so I want you to actually measure it and make them that size, and that's what I'm going to be checking for. All right, cool. Maybe we'll just do one more. Diameter refers to circle, right? So diameter, if you have a circle, is all the way across. So this is going to be 4 centimeters across the circle. The nucleolus is going to be 1 centimeter. Okay, 6 by 1. So we would take the 6 and make it 3, and this 0.5, right? So 3 centimeters by 0.5 centimeters. And you get the picture. Okay, so I just wanted to help you out a little bit. Thanks, guys. I hope this is useful.